What's up, everyone? We're back for another lesson, and today we're starting out with solving some proportions. This is going to be our warm-up. So what I will actually want to do to you guys is challenge yourself. Try these yourself. Pause this video real quick and try these couple problems if you remember how to do them. So right now I'm going to give a second to pause the video for you to try it. So make sure you pause, try it. Okay, if you didn't pause, that's fine too, right? I'm also going to do one, and then if you want to pause after that one and try the next two and then check your work with what I do, that's also good too. Because once I show you how to do the first one, it's going to come back to you of like, oh, this is pretty easy, this is pretty simple. I remember how to do this. So that is the important part. As long as you guys try and you remember how to do it, then we'll be good to go. So for the first one, let's look at it. We have x over 22 equals 10 over 4. We want to solve for x. Now, some of you might remember how to do this, but some of you may not. Our thing that we have to do is called our cross multiply. We want to cross multiply x times 4, which will give me 4x equals 22 times 10, which will give me 220, right? And now you just have a simple one-step equation to solve here. How do we get rid of that 4 next to my x? Well, 4, it's like 4 times x. So we do the opposite, which is division, right? We divide both sides and we get x equals, not gonna lie, gotta use my calculator here. Too early for me to do all this math thinking. All right, awesome. So it's 55. Never shame in using a calculator. Sometimes your brain isn't awake yet. So all we did was we cross multiplied. And then we just solved our one-step equation. So now, if you didn't pause originally, or even if you did and you got this one wrong and you want to redo your next two, challenge yourself and try the next two, right? So try them out real quick. Pause the video, and then we'll get back to it. All right, so if you did pause, and now you have your work done, now you can follow along and check your work. If you didn't pause, at least copy this down and pay attention. So once again, we are cross multiplying for my second problem. That gives me 5 times 5, right? 5 times 5 gives me 25. And then 23 times n will give me 23n. Now we got to divide. 23, 23. I'm going to cancel on this side. And I'm left with n on my right side. On my left side, we're not going to simplify this. We're just going to leave it as 25 over 23. We could simplify, and if you did, and you want to just check, our answer would be about, I'm going to round it, 1.09. 1.09. I like leaving it as a fraction in this sense because it's not necessarily, this number goes on a lot more. I rounded it at that. It really should be 1.0869565 and then it goes on even further. That's all the calculator shows me, right? So rounding works here. And my last one, change colors up. Purple. Last one, we have 16 times y. Will give me 16y. I'm going to show you something really cool with this one. And then 16 times 8, which will be, not going to lie, once again, pulling out my calculator, 128. But when we notice, when we do our opposite, our inverse operation here, right, we get y equals 8. And why do we get y equals 8 when we do 128 divided by 16? It gives us back to that number. And the reason is, this is a 1-to-1 proportion, right? 16 over 16 is 1. So that means this is just going to be 8 over 8. And that's how that works, right? So it's just going to be 8 over 8. It's the 1-to-1 proportion. And these are our answers. Oh, I didn't box off my green answer. Box that off. Oh, it looks sloppy. Boxing off answers make everything look neat and nice and points it out, right? And so this is just cross multiplication. This is going to be something, a skill that we're going to be using today that we technically learned in algebra, but we're going to be using today in our geometry class. So let's actually hop into our lesson now that the warm-up's done. Our lesson is called Keeping It in Proportion, and we're going to be talking about theorems about proportionality. So Our learning goals for today is use proportional side theorem, triangle proportionality theorem, the converse of the triangle proportionality theorem, proportional segments theorem associated with parallel lines, and then the triangle mid-segment theorem. So basically, we're talking about a lot of theorems, and we're going to be applying them. Now, it's not going to be as complicated as it might seem by just, oh my God, all these theorems, right? Because they're basically the same thing, right? They all follow the same type of rules. So once you see it, it'll be a little easier, right? So our first one is the angle bisector slash proportional side theorem, right? That's what this is called. Weird name. All you have to know is if you see the situation, what you could do during it, right? So the angle, it states, right, a bisector of the angle in a triangle divides the opposite side in two segments whose lengths are the same ratio as the lengths of the sides adjacent to the angle. Wow, that's a lot of words. So let's actually look at the picture and dissect what this means. Well, the first thing that we have is the bisector of an angle. If we forget what that is, that's fine, right? So let's remember right now. Sometimes we forget things. Down here, this line that's cutting across my bigger red triangle bisects this angle, right? As we could see, we have these two green arc dashes here to notify us that those two angles are congruent, which means that the bigger angle was bisected. It was cut in half, right? So when we have that to happen, when we have an angle cut in half, when an angle gets bisected, what it says is the two sides on the one side of that bisector, if we put them in a ratio, A over C, is equal to the two sides in the ratio of B over D. Like we have here, A over C equals B over D. That's all this is saying. You take the two sides on, or the two segments on the one side of that bisector and the two segments on the other side of the bisector, and you put them in ratios, they will be equal. That's all that's saying. So let's look at it in an actual problem, how we can apply it. And we're starting off with a word problem today. Oh, I hate word problems, mister. Yeah, everybody does, but they're really good for your brain. So that's what we're working on. So it says on the map shown, North Craig Street bisects the angle formed between Belfield Avenue and Ellsworth Avenue. So let's look at our map here. This is North Craig going right here. It bisects. So we can say that these two angles here are congruent. That's something that we can know. Next up, it says the distance from the ATM to the coffee shop is 300 feet. Where's the ATM? ATM to the coffee shop. Right here is 300 feet. Distance from the coffee shop to the library is 500 feet. So we got 500 feet. Last but not least, distance from Kaya's apartment to the library is 1,200 feet. So right here, 1,200 feet. Now, what do we want to know? In the blue, it says what we want to know. It says determine the distance from Kaya's apartment to the ATM. So we want to know, let's say right here, boom, that X. And this is just because it doesn't look like the triangles that we just had. We actually have these triangles here, right? Boom, boom, boom. We got a triangle right here. Call that triangle A, and we got triangle B here, right? And it sets up those ratios just like we had. So what we could do using that theorem we just learned, we could say X over 300 equals 1,200 over 500. And boom, we're done with using that theorem, right? We use the theorem to set this up. Now it's just going back to what we did in our warm-up, right? What you guys learned in algebra. We're done with the geometry part here. The only geometry part was able to set this up. Everything else we should be able to know, right? So all we have to do is cross multiply. So I'm going to do some different colors just so it could really stand out. We get X times 500. That's my first thing, which will give me 500x. And then in purple, we have 300 times 1,200. Once again, I'm going to a calculator here. Never going to lie to you guys about that. Just easier this way. We have calculators in our pockets at all time. So 1,200 times 300 is 360,000. 360, 1, 2, 3. And obviously, once again, we have 500 times x, so we have to do the opposite, which is divide both sides by that 500. Cancels here. We get x equals, and then we just go to our calculator and do 360,000 divided by 500. We get 720. But what does this 720 actually mean? That's the distance from Kaya's apartment to the ATM. So 720 feet. And it's the distance from Kaya's apartment to the ATM. That's what that stands for. But all I did was we just used that idea to set it up in a problem that it might not look so, it looks kind of complicated. But this could be a real life thing, right? If this is a real life map, right? This looks like it could be, these streets, the way they're set up, looks like it could be part of a city, right? And this could be used for that type of thing, right? So let's look at a simpler problem, right? And it's just a simple plane triangle. Now this one might be easier for us to digest based off of what we just did, but we're using that same theorem. So first of all, it says CD bisects C, right? So CD here bisects C, which means that these two angles are congruent. And it wants us to solve for dB. So I like to give them a variable. I like using X because it's the most common one. Use whatever letter you want there, right? You like J, L, U, whatever you want. And all we have to do, once again, is set up our ratios. Now, the best thing is, it doesn't matter if we do 24 over 8 or 8 over 24, right? For our first one. I like to go from top down. As long as we can't do 8 over x and 24 over 30. That doesn't work, right? Because they're on opposite sides of that line. It's on opposite sides of CD, that angle bisector. The two numbers in the same fraction have to be on the same side of that bisector. So we're going to do 8 over 24. 24 equals x over 30. Now, before we go on with this problem, I just want to give you guys some tips and some things that you could think about. So when you get your answer, you could have an idea if it's right or not. First things first, if we notice, we look at our first fraction, we have our smaller number up top and then our bigger number down below. So when we find x, one thing that we have to know is it has to be smaller than 30, right? In order for this to hold true and be what we call proportional, that number up top has to be smaller than 30, right? So when we do this problem, that's one thing to keep in mind. So now let's jump into that problem. Once again, I'm going to use different colors just to divvy everything up, and we'll get 24 times x, which will give me 24x, equals 8 times 30, which will give me, I want to say 240. And then we divide by 24, and this one's the easy one. We divide by 24 on both sides. Cancels there. We get x equals 10. Boom, boom. Which means right here, we could say this is equal to 10. So really, dB is equal to 10. X equals 10. dB equals 10. Awesome. Now, one thing we could also do is if we look at 8 over 24. This is a little side work. Let's do side work. 8 over 24. If we simplify this, let's say we divide the top by 2, bottom by 2. It's going to give me 4 over 12. Then we do that again. Divide it by 2. Divide it by 2. That's going to give me 2 over 6. And then one more time. Divide it by 2. Divide it by 2. That's going to give me 1 over 3. See how it simplifies to 1/3. Now, if we take our new fraction, 10 over 30, and I'm going to do this a little quicker because it's easier to see. And we divide the top and the bottom by 10, not just 2. What's it going to give me? 1 over 3. These fractions are equal. That's what it means to be proportional. That's how we could check our answers too if you really want to. You could simplify those fractions and show that they're proportional. So that bottom work is just to check our answer. That's not to get to the answer. We already got the answer. The answer was 10, right? But now we could check our work. Magical thing math is. Let's move on. Let's see another one. Once again, we have another example, right? I'm going to fill in my x here. And all we have to do is set it up. So what do we have going on? Same situation. DC is our angle bisector. So these two angles are congruent. So everything on the left side of that DC is going to be a fraction. And everything on the right side will be a fraction. So we're going to have 9 over x equals 11 over 22. Once again, we cross multiply. So we get 9. Get 9 over 22. And that's going to give me 9 times 22. You know what? Once again, not going to lie to you guys. Don't feel like doing that in my head. Give me 198. Now I know some of you can do that stuff in your head really quick. That's good for you. I don't have that skill. Never did. Good at math. I could figure out math, but I can't do quick multiplication like that. And now all I have to do is divide by 11 on both sides. 198 divided by 11 is going to give me 18. Right here, they cancel. Yeah, x equals 18. Once again, if you really wanted to, you could check your work. I'm not going to do that for every slide, right? Not going to do that for every slide. Now, another thing that we could point out here is you might realize, hey, well, 11, if you just multiply it by 2, it gives me 22. So then 9 times 2 would give me 18. That works too. That's how this works. It's that simple, right? It's that easy. So that's what it means to be proportional. Whatever you do to go from one side to the next on the one, do the same thing for the other side, and you're good to go. All right. So for this next problem, let's see what we got going on. Kind of a similar problem, but some things are going to be a little bit different here. So it says AD bisects A. So let's mark off our angles like we've been doing. Right here, those angles are congruent. That's what a bisector means, right? And that means it sets up our ratio. But the problem here is, look at AB and AC. They don't have any values. Instead, it says AC plus AB equals 36, right? So this creates a new situation for us. What we're going to have to do is something like this. I'm going to say AB equals X, right? And then what we could do here is we could say that AC plus X equals 36. So in order to figure out what AC is, what we could do is we could then say minus X on both sides. And we get AC equals 36 minus X. So this side here will be 36 minus X. Awesome. So then what we could do is now set up our ratios. So same thing. You set up ratios based off of what's on one side of that line that's cutting this bigger triangle. So we're going to say 36 minus X over 7 equals X over 14. And once you have that ratio set up, it's basically the same thing that we've been working on. Now this one's going to be a little different, once again, because of the fact that when we cross multiply our first one, we're also going to have to do what we call distribute, right? Because that numerator, 36 minus X, is 2 terms, we're going to have to say is 14 times 36, which gives us 504. And then 14 times a negative X, which will give me negative 14X equals color. And then we get 7 times X. We get 7X. And I'll switch back to red. Right? So you cross multiply there. You have to distribute the 14 to 36 and then negative X. And we cross multiply 7 times X and get 7X. Now we can solve this. First things first, we got to get our X's together, but they're on opposite sides of the equal sign. So we have to do the opposite, or the inverse operation here. I'm going to add 14 to both sides. What's that going to give me? 504 equals 21X. And now we just have to divide. Just like we've been doing. We divide both sides by 21. 21. We're going to write the answer over here. We get x equals 24. Awesome. But this isn't our final answer because nothing here says, hey, what is x? No, you want to solve for AC and AB, so we have to plug it back in. AB is easy. We could just say it's 24. But for this one, it really has to be 36 minus 24, which is going to give me what? Which will give me what? We do 36 minus 24. We get our answer to be equals 12. Boom. And so AB is 24. AC is 12. There we go. We solved the problem. Now, this problem is a little more confusing. So if you did struggle with it, be sure to ask me, ask Miss Harris, ask your teacher if you're watching this from another class, or message below in the comment section. Say, hey, I have this question or I have that question. If you have a question about it, though, don't be afraid to ask. That's what we're here for. That's why we teach. All right, let's move on to the next one. And let's go over another example of this. And you might be saying, wow, there's so many examples today. It's better to see more examples than less examples, you know? And now, be careful here because it's asking us to solve for AC, not just DC. We need to know what DC is, but it's asking us to find this whole line. So once we find one of them, we're going to have to find the other. So once again, set up our ratios. Now, triangles are now top and bottom, so we're going to do top triangle over first. 14 over 6 equals 16 over, once again, we're going to call it x. And now this should be almost like second nature at this point. Then we cross multiply. And we get 14x equals, once again, cross multiply, 6 times 16. And we get, calculator, help me out here. 96. And then we just divide by 14. Divide by 14. Boom, cancels there. And we get x equals, what a gross number. We are going to round. And I'm going to round it to the second decimal place. Okay, so we're going to say it's 6.86. That's round it. This is 6.86. So when it asks us what AC is is about, that's what these squiggly mean, 12.86 from AC. Sorry, guys. Floppiness. AC is about 12.86. We solved for the whole entire side of the bigger triangle. Cool. Now, just before we move on, once again, if you have any questions about any of these problems I've gone over, pause your video and raise your hand in your Teams chat right now and ask me or ask Miss Harris, right? Or if you're watching this in another geometry class, ask your teacher, right? Don't just watch the video and go, if I don't understand this, oh, well, too bad. Nah, ask your teacher. They'll be more than happy to help. That's why we're teachers. That's our job. It's what we like to do. So make sure you ask for help or ask clarification. Or if you're just confused, just be like, hey, this guy on my screen's talking and I don't really understand it. And someone will be there to help you out, right? But with that said, let's keep it cruising. Now we have a new theorem. It's called our triangle proportionality theorem. And this one has to do with parallel lines inside of a triangle. It says, if a line parallel to one side of the triangle intersects the other two sides, then it divides the two sides proportionally. So what does that mean? I drew a little example down here and we have a little phrase. If DE is parallel to BC, which we see with those arrows that DE is parallel to BC, then we can say that AD over dB is proportional or equal to AE over EC. So once again, kind of like what we did in the last one. This is what I said when we were looking at our learning goals. They're kind of similar, a lot of these. We're just putting things in proportions and solving. So this top portion here over this bottom portion is equal to this top portion over this bottom portion. Let's see it in action, right? Now, of course, we're going to start off with a little bit of a harder problem here because we don't have this top portion right here. So we have to figure it out. In order to do that, we could do 18 minus 4. 18 minus 4, right? Because this whole side's 18. We don't care about the whole side. We want to know what that top portion is. So if we're trying to figure out that top portion, we just take away the bottom portion from 18. That's going to give me 14. This top part is 14. Now, what can we say? We know that these two lines are parallel. We can set up our proportions. So we can say 14 over 4 is equal to x over 6. And once again, we just do the same steps. We've been solving proportions all day. We should be masters at this point. Cross multiply, 14 times 6. That's going to give me, once again, I'm not doing that math. Early for me. 14 times 6. 84. 84 equals, cross multiply, 4 times x is going to give me 4x. And then since 4 is right next to x, that means they're multiplying. We want to do the inverse operation, which is divide both sides. Cancels on my left side, and we're left with x. On the right side, we get 21. So x is going to be 21. Boom, finished our problem. See how quickly we could get through these now? And once again, what did we do here? Because some of us might be like, this looks exactly what we were just doing. It kind of is, right? Because what's going on is we have two triangles. We have the smaller one here. We have a bigger one here, right? And it just happens that they fall inside of each other this time. Because of those parallel lines, we know that they fall inside of each other. So we could set up these proportions here, which makes it so much simpler than what we've been doing. So let's go again. Now, this one's a little more complicated, once again, because we're math teachers. We like to make things a little harder for you. We see our parallel lines are now vertical, right? But we don't know this chunk right here. And we're also missing the bigger chunk here, but we have a variable for that. So what we could say, since we know this whole length, we could basically do what we did in the last one and say, hey, this chunk is whatever this whole thing is minus that bigger chunk, which is x. So what I could say is that this smaller chunk here is just x, or sorry, 20 minus x. So when we set up this ratio, what are we going to have, right? It's going to be a little gross. Up top, we're going to have 20 minus x. That's a 2. I meant to put a 20 over x equals 4 over 12. And you might be like, hey, mister, what did we do? How'd you get that? Well, look, I just follow this line. Boom. 20 minus x over x. And then follow this line. 4 over 12. Right? And now we cross multiply. Now, sorry about that. The biggest mistake I see here. Once again, we have two terms in that numerator. We have 20 minus x. Make sure you multiply that 12 by both of them, right? So we have to first do 12 times 20. So 12 times 20 is our first thing that we're going to do, which is going to give me 240. We're going to get 240 minus now 12 times the negative x, which will give me, boom, minus 12x. Now we could do our other side, right? And x times 4, which will give me 4x, right? And this kind of sets up the problem like we saw earlier in the PowerPoint. So now what can we do? What we could do here is we add 12x to both sides. Because this is a negative 12x, we want to add it to both sides. It's going to cancel on my left side. I'm going to be left with 240 equals 16x. And now we have that one step. All we have to do is, since it's a number next to a variable, we divide by that number to get rid of it. And then we do that on both sides. So we get 240 divided by 16 is going to give me 15. And over here, we're left with x. So we now know that x equals 15. So x equals 15. So this segment here equals to 15. Up top, this is really like doing 20 minus 15, which is going to be 5. This top chunk here is 5. The bottom chunk is 15. 5 plus 15 gives me 20. That's how we know that we got the right answer. Beautiful. Beautiful, beautiful, beautiful. Another way we could say is if you look, 4 times 3 equals 12. 5 times 3 equals 15. We're able to check our answers there. How we know that this also was done properly. Move on. Last little bit of information, right? We're talking about our converse proportionality theorem, right? Now just the converse of this line, or this, what we just said. Now it says, if these things are proportional, then it has to be parallel. So just the opposite of what we were just doing. We said, since they're parallel, these things are going to be proportional. So we're able to set it up. Now we want to show, are these lines parallel? That's basically what we're going to be trying to do here. So you're given all of your information. And now we just want to show, yeah, they're going to be equal. We could do this in 2 ways. I'm going to show you one way that I like to do it. Set it up just like we were setting it up. So make your proportions. So follow these lines down. So 2.7 over 7.2. So 2.7 over 7.2 equals, here, 4 over 9. And what I like to do is just cross multiply. And if both your sides end up equaling the same thing, then you are good to go, right? That means they're proportional, right? So we go 2.7 times 9. So once again, get out the calculator, and all we got to do is multiply. 2.7 times 9. We get 24.3. 4.3 equals, and on my other side, we get 7.2 times 4. So 7.2 times 4 equals 28.8. Are these equal? No, they're not equal. So that causes a problem here, right? These are not proportional. So our answer is not proportional, right? Another way you could check this is if you say something like this. If you take, I like doing bigger numbers over smaller. So if we say 7.2 over 2.7, and what does that equal? Right? So it's just another way to show that they're not proportional. 7.2 divided by 2.7 gives me 2.66 repeating. So 2.66 repeating. That bar over the 6 means that it's repeating, right? And then we could do the same for the other side. 9 over 4. So bigger over smaller. 9 divided by 4. 4 gives me 2.25, right? These aren't equal numbers. So once again, they don't work. So these lines are not parallel. That's what we could say by this. They're not parallel. Not parallel. Awesome. Because the numbers aren't proportional. This is using the converse, right? Now, you don't have to do both things each time, right? We don't have to do both things on both times, right? Just got to do one of them. So I like doing the first one. Obviously, the first one feels easier for me. Now, if you like doing the second one where you just divide and see if the numbers match, that works too. So once again, let's set it up. So I'm going to go 3 over 24. 3. All right, let me go to red. 3 over 24 equals 4 over 32. And once again, we cross multiply. 3 times 32 is going to give me 96 equals 24 times 4 is also going to give me 96. So what do we notice here? These numbers match. Ching! So what can we say? We can say that MN is parallel to PQ. Beautiful. You love to see it. You love to see it. And this is using the converse of that theorem that we came up with. Now, we have a last theorem here, right? I told you there's a lot of theorems, but as I said earlier, things are kind of easier. And this is called the triangle midsegment theorem. This one's pretty simple. The midsegment of a triangle is parallel to the third side of the triangle and is half the measure of the third side. So all you have to know is the midsegment is going to be half of the other side. So as you can see here, the base is 16. So then our midsegment is 8. And these two lines are also parallel. So we can use it here. Let's look at this problem. It says, Ms. Zoid asked her students to determine whether RD is the midsegment of triangle TY. It says TY is 14 and RD is 7. Carson told Elisa that by using the triangle midsegment theorem, he could conclude that RD is a midsegment. Is Carson correct? And how should Elisa respond if he is incorrect? So here's the thing. We can't tell because we're missing part of the criteria. What we do know is RD half of TY? Yeah, 7's half of 14. But we don't know. We don't know if TY, I don't like that Y is parallel to RD. So then we can't say. They might be. But if we can't prove that they're parallel, then we can't say that this is true or this is not true, right? Just because they're half doesn't mean anything. We could get that situation to occur if they're not parallel, which means then they wouldn't be the midsegment. So at this point, we can't say if it's true or not, and Carson isn't right. So Lisa could just say, hey, we don't know if they're parallel, so we can't say for sure if this is true. Awesome. And that's our end of our lesson. I know we went through a lot of stuff today, right? Once again, if you have any questions, make sure you ask. If you need to, go back and rewatch a part that you might be confused on. Reread through the theorems. I know it sounds boring. I have to read math, but it could help you out a lot. Guys, thank you for paying attention. Thank you for taking notes. Once again, if you have any questions, let me know. Also, you can put them in a comment down below on the YouTube video if you have a question, and I will try to get back to you on there. Thank you for watching. Peace out, everybody.